We've taken the last several days to learn how to solve trig equations. And so the next thing that we're going to move into is solving word problems using trig equations. Now, the thing about it is that it's just word problems are just math problems with no pictures. And so we have to convert those words into pictures to make it much easier to do. Once you get the problem set up, once you get the picture drawn, then it makes it easier. So the first thing we need to talk about is a couple of vocabulary words that we want to understand. Angle of elevation and angle of depression. Really, they're not anything magical. It's just understanding what it means when you see it. So the angle of elevation is as though you are standing on the ground and you are looking up at, say, a hot air balloon. Okay, it's from the ground up. The angle of depression is though you're standing in the hot air balloon and you are looking down. Now the thing about it is that the horizon, right, horizontal lines are parallel, which means that this angle here, this angle of elevation, and this angle of depression are actually alternate interior angles, which means that the angles are congruent. So really what that comes down to is it doesn't matter what it is called in the problem. You're going to draw your right triangle however you want to draw it, and every picture is going to end up being a right triangle. You're going to draw your right triangle, and your angle of elevation or your angle of depression, either one, whatever it's called, is going to be off of the horizontal line. So it's going to be between the hypotenuse and the horizontal line every time. So really that's what you need to know about it. So let's take a look at some of this. A ladder leaning against the wall makes an angle of 74 degrees with the ground. If the foot of the ladder is 6.5 feet from the wall, how high on the wall is the ladder? The first thing you have to do is draw a picture. So we have a wall and we have the ground, and you can imagine standing to the side and you can see the ladder leaning against the wall. So you should be able to like envision that right triangle right there. Now, where to label everything. Think about where the pieces will go. The ladder's leaning against the wall and it makes a 74-degree angle with the ground. So if this is my ground, then this is my 74-degree angle. The angle, I've got too many zeros going on there, 74 degrees. So my ladder is leaning and it's making a 74-degree angle with the ground. The foot of the ladder, which is the bottom, right here, the bottom of the ladder, is 6.5 feet from the wall. So I'm going to put my 6.5 feet right there. How high up the wall is the ladder? So we put our X right there. Well, now ignore the rest of the picture and simply look at that right triangle. Now the assumption is that the building is square with the ground. And so we have our right triangle. So now we go back to our steps. You look at your triangle, find your opposite, your adjacent, and your hypotenuse. So the ladder is my hypotenuse. My X is opposite the 74-degree angle, and 6.5 is adjacent to the 74-degree angle. Well, the opposite side and the adjacent side have things on them, numbers or letters, and so I need to use TOA. So TOA would be tangent, so you set up your equation. So the tangent of the angle is equal to the opposite side, X, divided by your adjacent side, 6.5. So in this case, the variable's on top, so we need to multiply to get rid of that 6.5. So we do 6.5 on both sides. So 6.5, X is equal to 6.5 times the tangent of 74, which is approximately, as all of our trig answers are going to be approximate answers, 6.5 times the tangent of 74. Make sure your calculator is in degrees, and you get that the ladder is going to reach 20, and I didn't say what to round to, but since there's one decimal place in the problem, we'll go ahead and round to one decimal place. So it's going to reach to 22.7 feet up the wall. Okay, notice that we don't even need to know the length of the ladder. Because now we know how to deal with these angles, we only need one side to be able to find the rest. We're accustomed to using the ladder problem with Pythagorean theorem where we know two sides, and we don't have to do that. Okay, a ski run is 1,000 yards long with a vertical drop of 208 yards. So I've got my ski run. Now the run itself, so think about where you ski. So you ski down the mountain. So we ski down the mountain, so there's my 1,000 yards. Again, we know that it's going to be a right triangle. You can draw your right triangle however you want. Then you've got your vertical change and your horizontal change. It has a vertical drop of 208 yards. So from top to bottom, you have dropped 208 yards of altitude. Find the angle of depression from the top of the ski run to the bottom. Now again, remember that the angle of depression, it doesn't matter what it's called, it is always off the horizontal. So you find your horizontal line, which is this one right here, your horizontal, and you put the angle right there. That's where our X is going to go, always off the horizontal. Okay, it's always off the horizontal. So now you set up your problem. I have my opposite side and my hypotenuse, O and H, that's so. So I set it up, sine of X is equal to opposite divided by hypotenuse. And so I remember to solve that with an inverse, so X is equal to the inverse sine of 208 divided by 1,000. So you type in inverse sine 208 divided by 1,000. You find out that the angle of elevation is 12 degrees. Number 3. So we have a 1,500-foot cliff. So we draw a cliff here. So we have our cliff. A scout on top of a 1,500-foot cliff. So he's up here, and the cliff is 1,500 feet tall. Spots a campsite. So he's got a campsite down here. If he measures the angle of depression, again, it does not matter wherever you draw your triangle. So we're going to draw our triangle. The angle of depression is 33 degrees. Again, we always put our angle of depression off of the horizontal. So however you draw your picture, find the horizontal line and put your angle right there. How far is the campsite from the foot of the mountain? So here's the foot of the mountain. This is often a question, right? There's your foot of your mountain. It's at the bottom of the mountain. And so how far away is the campsite from the foot of the mountain? There are tools that you can measure these angles with. That's how we could get those angles. There are actually tools that you can use in surveying that can calculate or can determine those angles. So we look at what we've got. So the 1,500 is the opposite side from the angle. The X is the adjacent side from the angle. TOA, T-O-A, tangent uses O and A. So you set it up. The tangent of 33 is equal to the opposite side divided by the adjacent side. This time the variable's on the bottom. If it helps, put that over 1 so that you can see that you would cross multiply that 1,500 times 1 divided by the tangent of 33. So you have 1,500 divided by the tangent of 33. And you type that into your calculator and you get that the cliff or the campsite is 2,309.8 feet away, or 2,323.10. It's approximately 2,309.8. Since I didn't say what to round it to, it's okay to not have it exactly. On anything that we ask you how to do, we would have to tell you that. We'd have to give you what to round it to on a question. A chairlift on a ski slope has an angle of elevation of 28 degrees. So a chairlift goes up the mountain like this. It has an angle of elevation. We know we got to start with a right triangle. So draw your right triangle and then envision where everything goes. So this is your lift. and it has an angle of elevation of 28 degrees. Always off the horizontal, find your horizontal line and put your angle there. The chairs are attached to a cable that is 4,640 feet long. So this is my cable, because your chairlift goes up the mountain, not into the mountain, like the horizontal would do. To the nearest foot, what is the vertical height covered by the chairlift? So this is what we're looking for, our vertical height. So we go in and we label our opposite side and our hypotenuse. That's O and H, so that would be sine, so katoa, so it would be sine, so it is the sine of 28 is equal to the opposite side divided by the hypotenuse. You can, you can put that over 1 if you need to see what you need to do, but to solve this, you would do x is equal to 4640 times the sine of 28. So 4640 times the sine of 28. Type that in your calculator and you find that you have moved up the mountain 2,178 feet. And it says to the nearest foot this time. So 2,178 feet. That's how much higher up the mountain you've moved. So the Uniform Federal Accessibility Standards specify that a ramp angle used for a wheelchair ramp must be less than or equal to 4.78 degrees. So it's not too steep for somebody in a wheelchair to be able to roll up the ramp. The length of one ramp is 16 feet. The vertical rise is 14 inches. Be careful with that. Pay attention to your units of measurement. So let's draw our picture. We have a ramp. Be careful, ramps are always on the diagonal. Lots of people put their ramps on the ground. Well, that doesn't make much sense. What good would a ramp be on the ground? So we have a ramp. The length of the ramp is 16 feet and the vertical rise is 14 inches. We need those to be the same. So I'm going to change my 16 feet. Okay, 16 feet is 16. If you do 16 times 12, you will get that it is 192 inches. It doesn't matter which one you change. You could change your 14 inches to feet, but it's a little bit harder. You would do 14 divided by, but you'd end up with a decimal. So that's why I converted feet into inches. It just made it a little bit easier. So 192 inches. The ramp, the vertical rise is 14 inches. So my vertical, I put that on my vertical. And the question is, what is the angle? So there's the angle of the ramp with the ground. So if we test that, we have our opposite over our hypotenuse. So that's sine. So we do the sine of the angle is equal to 14 over 192. If you take the inverse sine, so type it in, inverse sine of 14 divided by 192, you get that the angle is 4.18. So x is 4.18 degrees. So the question is, does it meet the Uniform Federal Accessibility Standards? It has to be less than or equal to 4.78. So yes, it does, because it's less than 4.78. So number 6, you're flying a kite with a 20-foot string extended. So think about what that looks like. You've got your kite going up here. There's your kite. And it is flying above the ground. Here's your ground. Now, you're standing over here. Remember that kite strings go out at a diagonal. You never fly a kite directly over your head. So we've got a 20-foot kite string extended. The angle of elevation from the spool of string to the kite is 41 degrees. So the spool's down here. That's your angle of elevation. So we put our 41 degrees right there. How high is the kite if you're holding the spool 5 feet above the ground? Now that's important. We're holding the spool 5 feet above the ground. So what that means is that there's an additional 5 feet that I need to consider. But we don't need that until the end. we always assume basically that we take out the height of the person, we take out the height of holding something, and we just assume that it's not there. But in this case, it wants you to include it. But we'll add that back in a minute. So we do this just like we always have. This is the opposite side and the hypotenuse. So that's going to be sine. So you have the sine of your 41-degree angle is your opposite side divided by your hypotenuse. So you would multiply both sides by 20. So x is equal to 20 times the sine of 41, which is approximately 13.1 feet. Now that's without the holding the 5 feet above the ground, so we need to add that 5 feet back in. So the kite is actually 18.1 feet off the ground. All right, so last one. This one is a kind of a bonus question, so think about what this would look like. So we've got a helicopter up here flying around. Okay, so we got a helicopter up there. We've got Bo and D, and they're watching the helicopter. Notice that their angles of elevation are 20 and 25 degrees, which means they're not standing in the same place. So the helicopter is above the ground. And then we've got our people, Bo and D, and Bo is at 20, so it says respectively, which means Bo is 20 degrees, and D is looking at it at a 25-degree angle. So think about if you were looking up at something, if you went closer, you would have to raise your head more, which increases the angle. So the person with a bigger angle is standing closer to the object than the person who is standing farther away. So this is where D is standing, and this is where Bo is standing. D has a 25-degree angle, and Bo has a 20-degree angle. When you back up, you don't have to look quite as high up with your chin, and so the angle's lower. So the question is, how far apart are they? So this is a really great bonus question. So what you want to do is this. Let's just look at this triangle for D. Let's look at our green triangle, and the helicopter is 50 feet high. So I want to know how far apart they are. Well, let's first find out if they were standing underneath it, how far away D is. So first let's find X. So let's find out how far D is away from being underneath the helicopter. So that would be tangent. This is opposite and adjacent. So the tangent of 25 is equal to opposite over adjacent. So that means that X is 50 divided by the tangent of 25. So that is 107.2 feet away. So D is standing 107.2 feet from being directly underneath the helicopter. So that is my green triangle. So now let's look at this red triangle. So now let's look at the triangle that's formed by Bo. Okay, so let's switch to red so we can do everything. So this time now we're going to do this side of the triangle. So let's call that Y, the whole side. Just ignore everything that has to do with D. Ignore the X, ignore the 25, ignore that line. So we still have opposite over adjacent. So we would do the tangent of 20 is equal to opposite over adjacent. We'll call Y this time. You can call it whatever you want, but that's just easy. So we solve this by doing 50 divided by the tangent of 20. So 50 divided by the tangent of 20. Notice the problems are very similar. The only thing that changes is the angle. So it says that Bo is standing 137.4 feet away from being underneath the helicopter. And the question is, how far apart are they? So you would take 137.4 and subtract 107.2, and you get that they are about 30 feet apart. So whenever you have word problems, you want to draw your picture. You know that these word problems are going to be right triangles because that's the unit that we're in. So draw the right triangle and then decide what goes on the horizontal or what goes on the vertical or what goes on the diagonal. And then where does the angle go? The angle will always go, unless you are specifically told otherwise, the angle will always go off of the horizontal. Draw your picture, then go through your steps. Your OAH, then decide your sine, cosine, tangent.